The previous video was about the ADH. ADH is also called the vasopressin hormone, vaso blood pressin pressure, the hormone. The next complex we're going to talk about, this is a combination of different hormones, is the renin angiotensin aldosterone system, or AAS. R for renin, um, the first A for angiotensin, the angiotensin, and then the next A for aldosterone, S for system. It's a very complex negative feedback loop for homeostasis. This is the one that actually is directly connected to drop in blood pressure. Both ADH and RAAS works on drop of blood pressure, but RAAS works with a drop in blood volume also. So I'm going to talk about how this works in a second, as soon as I can get this slide to move. Angiotensin, angiotensin basically stensin 2 basically increases blood pressure, decreases blood flow into the kidney, and it stimulates the hormone aldosterone, which increases blood volume and pressure. I'm just reading out of it. The next slide is more detailed, and I'll explain that. Okay, so there you go. This is more detailed. Step one, basically, if there is a drop in blood pressure around the glomerulus, around the nephron area, which is a low blood pressure, this low blood pressure, the stimulus for this could be anything. It could be acute blood loss because you got shot. Please don't get shot. Or dehydration. You are hiking through the desert and there's an acute dehydration, so the blood volume has gone down. This also can happen because you have a cardiac condition. You might have some kind of plaque buildup in your arteries. If you have plaque buildup in your arteries, that reduces the amount of cardiac output, or you could have a problem with a valve in your heart itself, so the amount of blood that's pumped out of the heart might be just lower, or there could be a very high pressure because there's something blocking the artery. So if you have a plaque buildup in the artery, the blood flow reduces. So there are multiple reasons why this can happen. Angiotensin, the RAAS system, not only is connected to the urinary tract system, it's also connected to the cardiovascular system, and that goes for all the hormones we're talking about. Antidiuretic hormone, because all these hormones are based on the volume and the osmolarity of blood, these things, the urinary tract system is very closely connected to your heart, the cardiovascular system. So the volume of blood can be reduced because you're dehydrated, because you have blood loss, or you have a heart condition because of which there's been a low cardiac output. So once that happens, basically the renal cortex pumps out an enzyme, a hormone called as renin. Renin then, so this is a part within the kidneys itself, renal cortex. Renin, it then stimulates angiotensin 1. Angiotensin 1, a very good example for that. If you remember the digestive tract system, you had pepsinogen, which needed to be activated using the HCl to become pepsin. Angiotensin 1 is similar to that. It is an inactive form of angiotensin. It has basically on one end, it has a peptide bond, a couple of peptides. That peptide bond needs to be cleaved and broken up so that it becomes an active form. The active form of that is angiotensin 2. ACE, you've heard this in a lot of different heart medication commercials. You've also heard, mostly you'll hear it a lot in Viagra commercials. If you are on an ACE blocker, you cannot take Viagra because blood pressure. ACE stands for angiotensin converting enzyme. So renin activates angiotensin 1. Angiotensin 1 then interacts with the ACE and then becomes angiotensin 2. Angiotensin 2 basically eventually constricts the arteriole, so the amount of blood coming into the kidney itself is reduced. It also so there's not a lot of blood loss that's happening. So there's no, when I say blood loss, I mean blood volume loss. The water from it is not lost because it's not being processed through the kidney. So by constricting the arterioles, the amount of blood getting into the kidney is reduced. So the amount of blood going through the kidneys and the water being taken out, that has gone down. Then it also, angiotensin 2 stimulates the adrenal gland. Add on top, renal, kidneys. It is a gland on top of the kidneys. The adrenal gland, besides producing aldosterone, also produces epinephrine and norepinephrine. Both of these are sympathetic hormones. Flight and fight syndrome, they are a part of that. So they don't make you hungry. Instead, they make you run away or stand up and fight, whichever works for you. Aldosterone, so aldosterone in turn increases the permeability of of the distal tubules, so more water and sodium ions are reabsorbed into the blood. Because they're reabsorbed into the blood volume increases. So just to like kind of navigate this path all over again, RAAS is a part of the homeostasis process. If there is, it maintains blood pressure as well as blood volume. They are interconnected. The more volume there is, the more pressure there is. So if a stimulus is, usually the stimulus is around the juxtaglomerular apparatus, which is this whole system, right there. The stimulus could be a low blood volume. Low blood volume or blood pressure could be due to dehydration, blood loss, or loss in cardiac output. So once that happens, the renal cortex, so remember we drew the kidney out and the cortex was on the outside. The renal cortex releases a hormone called renin. Renin then allows for angiostensin. This angiostensin comes from the liver. Renin converts that into angiostensin 1. Angiotensin 1 then interacts with the ACE, which is the angiotensin converting enzyme, ACE, and then that converts it into angiotensin 2. Once angiotensin 2 is converted, it reduces the size of the arterioles. It constricts the arterioles, does not allow more blood to go into the kidneys itself. So there's no processing of the blood. There's no loss of water that's happening. So the blood volume increases. On the other hand, it also stimulates the adrenal cortex. The adrenal cortex then pumps out aldosterone. Aldosterone then eventually leads to the reabsorption of sodium ions and water in the distal tubules, not the proximal, but the distal, in the distal tubules, which then increases blood volume. I hope this is clear. But like I said in the beginning of the video, somewhat in the beginning, that ADH and RAS, both of them increase the permeability of the tubules, but only the RAAS responds immediately to the decrease in blood volume. So if you're shot, the first set of hormones that comes into play is the RAAS and then the ADH, not the other way around. The opposite of the RAAH is the ANP. So RAAS, the RAS, basically, I should just use the word RAS. RAS basically works if there is a decrease in volume. It is not always the case where there is a decrease in volume. There could be an increase in volume. Also, again, if you like to drink 80 gallons of water, then you're going to see an increase in volume. What ANP does is basically it does the opposite of it. So let's go back to the picture and I'll tell you what is happening. So if ANP, if there is an increase in volume, so there's an increase in blood pressure, there's an increase in volume. If there's an increase in volume, ANP basically cuts this path right here. Renin is not produced. ANP blocks renin from being produced. If renin is not being produced, angiotensinogen that comes from the liver is not converted into angiotensin 1. Then the ACE inhibitor, the ACE enzyme, that's the angiotensin converting enzyme, does not convert it into into two, and then that does not stimulate the adrenal gland, which does not produce aldosterone. If it doesn't produce aldosterone, Na plus and H2O is not reabsorbed. If it's not reabsorbed, it becomes a part of the pee. And if angiotensin tensin 2 is not produced, then the arterioles are dilated, they're much bigger, so more blood goes into the kidneys, more blood is processed, more urine, there is a greater urine volume. So it just works in the opposite by blocking. And remember, these most homeostasis paths, and we talked in the previous videos, except for two things, most homeostasis pathways are negative feedback loops. So when there's ANP in the blood, the system is basically just cut off at this stage. Nothing here is happening. So once that stage is cut off, everything from here doesn't happen. Angiostensinogen, which the liver produces, is an inactive form. If it's an inactive form, it really cannot, this whole system is lost, right? So unless you're going to produce renin, angiostensinogen cannot be converted, and if that's not converted, none of this other stuff happens. I hope that is clear. So that's ANP. So this is the last slide. The two questions for this, the first question that you have to answer here is going to be the pathway for the RAS and ADH with the opposing pathway of ANP. The question you have to answer is, how does the ADH, the RAS, and the ANP pathways work? So you can put them in bullet points and then just send them to me. The second question you have to answer is, how is the blood, the process of purifying the blood, of removing water and salts. So you need to go over the anatomy of it as well as the physiology. So the different parts through which the blood moves at different stages, what is absorbed, what is reabsorbed, what are the different organs involved in it, what is the job of the kidneys, the job of the ureter, the job of the urethra, the job of the urinary bladder. So just chart the pathway through which water is removed from the body. That's it. Have fun.